Dear students, I, Mr. Vishal Shaha, Assistant Professor, Krishna Institute of Pharmacy, Karad, welcome you all to this second session on the phenols. In previous session, we have seen the introductory part regarding the phenols as well as what is the acidity of the phenol, means why phenols are behaving like acidic. In that case, we have seen phenol is having the ability to lose the hydrogen, and due to which they are behaving like a acid. Also, due to the loss of the hydrogen, phenols are converted into phenoxide ion. These phenoxide ions are stable due to its resonance effect, and that's why also the phenols are behaving like the acidic compounds. Now after this, just we will see what are the learning outcomes of this second module. After this session, students will be able to explain effect of electron withdrawing substituent on the acidity. Now in previous part we have only discussed the acidity of the phenol. Now here we are going to discuss the effect of substituent on the acidity. Then next outcome of this session is explain the effect of the electron donating substituent on the acidity. We know that there are two different substituents. One is the electron withdrawing substituent and other one is the electron donating substituent. So what is the effect of these substituent on the acidity of the phenol, that we are going to discuss. Now the first point that we are going to discuss is effect of substituent on the acidity of the phenol. In that case, we are going to discuss the effect of electron withdrawing substituent on the acidity of the phenol. Now when strong electron withdrawing group is present on the phenol, strong electron withdrawing groups means what? Examples here: nitro group, then chlorine, then cyano group, aldehydic functional group, and the carboxylic acid functional group. We know that these are the different electron withdrawing groups which shows the electron withdrawing resonance effect. So all such groups, if they are present on the phenol, they increases the acidity of the phenol. So here we can see, for example, here this is the example of the phenol. This is the example of the orthonitrophenol. This nitro group is present at the ortho position, that's why it is known as the orthonitrophenol. Then here you can see, in addition to the orthonitro group, here there is a presence of the nitro group at the para position. So this is known as the ortho para dinitrophenol. So as you go on increase the number of electron withdrawing group, the acidity of that particular phenol is increases. Here phenol does not have any substituent. Here this phenol is having the one nitro group as a substituent, and in this third example this phenol is having the two nitro groups as a substituent. So if we go on increasing the substituent on the phenol, it increases the acidity. Further, the whatever these phenolic compounds are there, these phenolic compounds are stable due to its resonating structure. Now before that, just we will see or we will revise which are the electronic effects that we have seen, because the effect on the acidity is related to these electronic effects. Now we know that there are two electronic effects are involved. One is inductive effect and other one is the resonating effect. Now when there is a presence of the hydroxyl group, that is the oxygen, if it is directly connected to the benzene ring, then we know that it shows the resonance donating effect. Now due to which what happens, the whatever the oxygen atom is there, this oxygen atom donates the electron to the benzene ring, and net electrons that are present on the benzene ring are there, they decreases. Now here we are going to discuss the effect of this nitro group. We know that nitro group is showing strong electron withdrawing resonance effect. Means here what happens, because we know that nitro group is consisting of the oxygen atom as well as this nitrogen atom. Now if we compare the electronegativity of this nitrogen atom and oxygen atom, this oxygen atom is more electronegative as compared to the nitrogen atom. So due to which this oxygen atom withdraws the electron from the nitrogen atom. So the net electrons that are present on the nitrogen atom are there, they decreases. So due to which what happens, now nitrogen, as it becomes electron deficient, it will try to search the electrons from the neighboring atoms. So here we know that the carbon atom is present near to this nitrogen atom. This carbon atom is having also pi electron. Now as this nitrogen is becoming electron deficient, it will withdraw the electrons from the carbon atom. Similarly, as this carbon atom is a part of the benzene ring, it will withdraw the electrons from the another carbon atom. So due to which what happens, we can say that nitro group, which is a electron withdrawing group, as this nitro group will withdraw the electrons from the benzene ring. And due to this effect, as benzene ring becomes electron deficient, this benzene ring will withdraw the electrons from the oxygen atom. So the ability of the oxygen atom to hold the hydrogen atom that is present over here, it tremendously decreases, and the bond between oxygen atom and the aromatic system, that is the benzene ring, it becomes more stronger, and that's why hydrogen is easily lost. Now what is the meaning of stronger acid? Why this is acting as a stronger acid? Means those compounds which completely dissociate or completely donate the H plus ions, they are known as the stronger acids. And here as these hydrogen atoms, if they are quickly donated, then these particular compounds are considered as acidic compounds. So here, as if we increase the electron withdrawing groups that are present on this phenol, what happens, that the ability of that particular oxygen to hold the hydrogen atom decreases, and due to which these particular compounds are acting as a more stronger acids. Now another example we will study, where if there is a presence of the nitro group at the para position or the meta position, what is the difference between their acidity, whether they will be having the same acidity, because we know that they are having only one nitro group, that is the nitro group that is present only at the para position and the meta position. Means there is a difference only between the position of the nitro group, otherwise rest of the functionalities are same. Here you can see the resonating structures that are possible for the para nitrophenoxide ion. So here this oxygen atom is having negative charge which can be easily donated to this bond, due to which this pi bond is broken down and the electrons are shifted to this carbon atom. Because what happens, due to the shifting of these electrons to this carbon atom, this carbon's valency increases, it becomes 5, and we know carbon is having 4 valency, due to which it breaks the bond with this carbon atom and electrons are shifted to this carbon atom as shown over here. So these electrons are again shifted over here because this carbon atom is having extra electrons, so it donates its electron to this carbon atom. In this way this pi bond is broken down and it will be shifted to this carbon atom. From this carbon atom also, as we know, nitro group is involved in the resonating structure, so that's why this carbon atom shifts the electron to this nitrogen atom, and nitrogen will get the positive charge. Again, once these electrons are shifted to this oxygen atom, in this way this negative charge is continuously circulating over from the benzene ring over your nitro group when it is present at the para position, and due to which we can say this nitro group is also taking part in the resonating structure. Now if we observe the resonating structures for the your metanitrophenol, here you can see that in this case, when the nitro group is present at the meta position, it is not involved in the resonating structure, because you can see this charge, negative charge, is when passed to this particular carbon atom, again it is passed to this carbon atom. So this carbon atom, as it is having a negative charge, it will pass to this neighboring carbon atom, due to which this bond is broken down. Now from this carbon atom, this charge, see here, if this carbon atom, these electrons are passed to this particular bond, due to which this bond is broken down. So directly from this carbon atom, charge is passed to the this carbon atom that is present at the ortho position, and due to which the nitro group, when it is present at the meta position, it is not taking part in the resonating structure. That's why when substituents that are present at the para position, they are more stronger acidic as compared to the when they are present at the meta position. Also, multiple substitution by strongly electronic withdrawing group greatly increases the acidity of the phenol. In previous example, we have also seen when ortho nitrophenol is less acidic as compared to the ortho para dinitrophenol. For example, here you can see pKa value for 2,4-dinitrophenol is 4. 2,4-dinitro means what? Two substituents are present, and compared to the 2,4-trinitrophenol, it is 0.4. So tremendous decrease in the acidity is observed when the substituents are less, while if the substituents are more, then the acidity of that particular compound is more. Now next point that we are going to discuss about the effect of electron releasing substituent on the acidity. Now in previous part we have discussed when electron withdrawing groups, if they are present on the phenol, they increases the acidity. In opposite to this statement, when strong electron releasing groups are present on the phenol, they decreases the acidity of the phenol. Electron releasing groups means what? Alkyl groups, then this OCH3 as well as the NH2. These groups are considered as the electron releasing groups. For example, you can see over here what these particular compounds will do, that is the electron releasing substituent. Now we know when these functional groups like electron withdrawing groups, if they are present, what they will do, they will withdraw the electrons from the benzene ring. So net electrons that are present on the benzene ring, they decreases. So to make the electrons more, it withdraws from the oxygen. This benzene ring withdraws the electrons from the oxygen atom, and due to which net electrons that are present on the oxygen, they decreases, and that's why ability of the oxygen to hold the hydrogen decreases. Similarly, when electron releasing substituent, for example here we will consider this methoxy group. This group is electron releasing because the alkyl group donate its electron to the oxygen atom, due to which oxygen donates the electron to this benzene ring. So here what happens, net electrons that are present on the benzene ring, they increases. That's why it donates the electron to the oxygen, because this benzene ring is having more electrons, so these are donated to the oxygen atom, and as oxygen is having more electrons, its negativity increases and its ability to hold the hydrogen atom increases, because hydrogen atom is positively charged, and that's why when electron releasing substituents that are present, it decreases the acidity because hydrogen is not lost easily. Here we can compare the acidity of this particular compound. Nitrophenol is having 7.2, chlorophenol is having 9.4. So this is more acidic as compared to this, which is more acidic as compared to the phenol, then para-methoxyphenol and para-cresol, because they are having electron releasing group. So this is about the acidity of the phenol. Now you have to answer this particular question on the displayed on the test demos. You have to use this particular link by using passcode that will be provided on your group, you can use